Okay, so I think we're at the home stretch. So first we have the switch component, and um, this also has good sane defaults. Um, the only thing here is we want to make sure that the U class contains a meta for meta equals, then it creates parentheses, and then we're going to say blueprint spawnable component. That's to make sure that we know that blueprints can spawn this component. Um, and then because it didn't include it, we also want to make a constructor here. So below the generated body, we're going to do public colon, enter U switch component, parentheses, semicolon. And now what we're going to do here is going to be a little bit different from the way that we did this in Blueprints. So the way we did this in Blueprints was that we used Blueprint events and we bound the events. But for the purposes of this, we actually want to use C++ event delegates that are optimized for minimal cost when just calling them through C++. So right below um, our constructor, I'm going to make a macro that is called declare underscore delegate. And I'm going to look for the one that says one param. And this is going to be what we're going to call in order to instigate events through the switch component. So that the generator will actually be able to know when the switch component flipped, and we won't have to do it in a crazy complicated way. So we know that the first thing what I want to do is I want to define what the name is of this delegate, and so just whatever I type in will become the actual name. So it's going to be, I'm going to use F, which is a convention that they usually use, on, which is also a convention for delegates. It's like on, meaning like on this action performed, on perform this action, do this thing. So on switch flipped, and then comma, and then I'm going to add in bool as the type. So that means we have one parameter for this function, which is a bool, and that means that it can be bound to any functions that have one argument of a type bool. And then just in the same way that almost like this is the way we set this up if we were setting like a U function or U property, I'm just going to go right below this declaration. I'm actually going to make the variable now F on switch flipped. And then I'm going to call this on. We can just call it on switch flipped or on switch flipped delegate. And so, by the way, delegate, it might sound really complicated, but that actually means the same thing that is usually meant in English. Like if you have a delegation or you have delegated a task to somebody, basically you're saying that this is that person is responsible for and managing whatever that task is. So a delegate in C++ or C Sharp or what have you is actually just the one that is in charge of that event. So it's the one that you task and you work with in order to get that that work done. And so it actually is just exactly how the English word delegate means that. So it's actually like not as confusing as you might think. So don't be overly worried about it. Okay, now I have this switch component, but I need to actually implement the iSwitchable interface in order to do the next parts. So that way I can just go up to my class where I see it has that it's inheriting from public U static mesh component. I'm going to do comma I switchable interface. Oh, it needs to be public. So public U static mesh component, comma, public I switchable interface. And now I can go down and I can create the overrides for the try to switch or the try switch and the get switch state. So virtual bool try switch, select that. virtual bool get switch state, enter, and then we've got that one as well. Now we want to go to we're done with the public functions, and we're going to go to make everything else that we put in here protected. And so first of all, because components work a little differently in C++ than they do in Blueprints, they don't have the begin play as a... Well, actually, they do have begin play, but it's not an ideal way of working with them because you don't know what begin play is going to start first. Excuse me. So what we want to do is we want to have the ability to initialize the component and then uninitialize the component to make sure that we have the functionality that we need. And that just means that we know that by the time begin play has happened, the component will be initialized because initialize component happens first. So I'm going to type in virtual void initialize component, and we see that that's the one in the top option. So we hit enter, and then we're going to do another virtual void uninitialize component, and it's a top option, so I don't have to do any arrows. I just hit enter. And then we have both of those integrated into our class. Then I'm going to go down one, and we're actually going to have to make a U function. So we don't need to do anything special with it, but with this one, we do actually have to make sure it is a U function. So we're going to type in U function as the macro, and we're just going to leave it empty. But we're going to make a void on overlap begin. And this one is going to be a little bit confusing. So just follow along. But we need to make sure that this on overlap begin has the same arguments as the on begin overlap for the underlying component collision. So it's going to need to have all the same values. So I'm going to hit enter in the middle of the parentheses, and I'm going to type in U primitive component asterisk. So it's an instance. I'm going to call that overlapped component, comma, enter. And then I'm going to do a actor asterisk for the instance of an actor. I'm going to call this other actor, comma. Then I'm going to do U primitive component again, asterisk for the instance of a primitive component. Other comp, comma. That means that it's going to be the component, the other component that is being overlapped with. Then I need an int 32 other body index. Now, just to make sure that you know, whenever you're trying to make this match a signature for the purposes of an event, it actually doesn't matter what the name of the variables are. It does matter what the type of the variable is and the order of those specific types is. So you could technically name these whatever you want, and it will still work. But you can't make it not have a U primitive component, an A actor, a U primitive component, and an int 32 in that order, or it won't be able to count as a valid signature. So now I need two more. It's going to be a bool b from sweep. And again, we don't need to worry about these. We just need to make sure it has the same things that this expects, because we're not going to use most of these. And then so we have comma, enter, and then it's going to be const f hit result. And then this is an instance of not a class, but a struct. So the instance of the struct needs to have the and here, which is basically the equivalent when we're doing something like what we would be doing with a class, an instance U class, except for the struct, we do the and symbol. Then we're going to call this sweep result. And then we just go out of the parentheses here, hit the semicolon. And then, when we go in and we implement that, we're going to have a lot of fun with that. But don't worry, it's actually not as crazy as it seems. So, all right, then what we want to do is we need to have a play switch sound. So we're going to call this void play switch sound. And this is going to use a U sound base instance. So that needs an asterisk. And we're going to call that sound to play. And because we know this is not going to change, we want it to have the value const after the function and then semicolon. And then the last things we need functions for flipping the switch on and flipping the switch off. So we're going to do void switch on, parentheses, semicolon, and void switch off, parentheses, semicolon. Okay, then I'm going to hit Control-Shift-S. And now I just need to go and I need to actually make sure that we've declared, we've created all the definitions. So first I'm going to right click on the uSwitch component, show context options, generate definition. And then the first time it does that, then it'll show me all the ones that don't have definitions generated yet with the little squigglies. And so then we can do either right click, show context actions, or Alt Enter, generate definition. For try switch, select get switch state, Alt Enter, generate definition, go back to the .h, Alt Enter with initialize component selected, generate definition. Then go back to the header, uninitialized component, select that one, Alt Enter, generate definition. Go back to switch component.h, on overlap begin, Alt Enter, generate definition, back to the .h, play switch sound, Alt Enter, generate definition, back to .h, Alt Enter, on switch on, generate definition, then back to the .h, select switch off, Alt Enter, generate definition. Okay, now there's going to be a decent amount in this, so we're going to try to get through this as cleanly as possible. First is the constructor. And so first of all, I want to make sure that I'm going to make this never tick. So I'm going to find the primary component tick dot b can ever tick. I'm going to set that to false because we're not using tick. But then because I actually want these initialized component and uninitialized component to run, I need to actually set another value called b wants initialized component. And that needs to be equal to true. Because there's a lot of optimizations in the way the code is structured in the C++ classes. And so by default, it does assume you want tick, which is why we need to turn that off. But by default, it does not assume you want to initialize component because you don't always need that. So that we need to explicitly turn on. And that's it for that one. So then let's go to try switch. And this one, we just need to make sure that we're checking whether this switch is set to toggle or not. And so actually we need to add some variables here because we added in all our functions, but we didn't add in all of our variables. So we need to go back to switch component.h. And now we need to make the variables that we utilize for setting up our materials, setting up our switch sounds, setting up whether the switch starts flipped or unflipped, and then setting whether this is a toggle switch, and then also having is on as a property. So first thing I'm going to do is I'm going to do a U property edit defaults only, and then comma, and I'm going to put this in the category of switch. So that will actually change how this gets organized. And this, we need a material interface, which is the same way that we set this up before. So we're going to do the on material and the on button material and the off button material. So we're going to do a T object pointer, make that U material interface. And then the name is going to be on button material, semicolon. Okay, so now we also want our off button material. So I'm just going to select all of this, go down a couple lines, control, copy and paste. I'm just going to call this one off button material. And then I want to make 2 sounds. So I'm actually going to grab both of these. Control C, go down below a couple lines, Control V, except this time, instead of the material interface, I'm going to call this a U sound base. Then copy that, paste it into the next one. And then this is going to be on button sound. And then it's going to be off button sound. And then we want 3 bool properties that are going to relate to the way that the switch itself is going to work. So I'm going to actually copy the U property from this one here. Control V. But instead of using edit defaults only, I'm going to select edit anywhere. And then I'm going to make a bool. And we're going to make this B start with switch flipped equals false. Then I'm going to copy this one 2 more times. But this one is going to be called B toggles. And that one is going to be set to true. And then the last one is going to be B is on. And that one is going to be false. But for B is on, I want it to not have edit anywhere. I'm going to have it say blueprint read only. B toggles, I'm going to have blueprint read only and edit anywhere. Blueprint read only, edit anywhere. That means that on the instances or on the blueprints, you can actually set this value, whereas B is on, you can't set it, you can only see it. And then, yeah, there we go. I think we now have all the variables we need. So let's go ahead and jump back to the switch component.cpp. And then we're going to go into our try to switch. And so this, we need to determine what our goal state is going to be. And that's going to be based on whether this switch is a toggle switch or not. If it is a toggle switch, we want to flip whatever the current value of the B is on variable is. But if it's not a toggle switch, we just want its goal to be to turn on. So we're going to say, I'm going to delete this here. And I'm going to make a comment really quick. So // if this switch toggles, flip whether it is B is on or not. Otherwise, its goal is true. And now I'm going to make a const bool b goal state equals, and then we're going to use a ternary operator based on the b toggles value. So I'm going to say b toggles, and then question mark, which is the ternary operator. And then basically, if the value of b toggles is true, it'll do the first option. And then there's going to be a colon. And then if the value is false, the value of b toggles is false, then it will return the other option. So bool b toggles, ternary operator, not b is on, colon, and then otherwise it's just going to be true. And this is useful. You don't always need to use a ternary operator. For example, you could say, do this a simpler way, but I just want to make sure that you understand it. So we could, if we commented out this line, we could make this const bool b goal state equals true. And then we could say, if b toggles, then we could set b goal state equals not b is on. And actually, but this one we wouldn't actually, it could not be a const value because we have to set it. But that's part of why this is actually more efficient to do it with the ternary operator, is you can make it a const variable, because the only time you're actually setting it is at initialization, even though you're doing the logic there. But I just want you to know the ternary operator basically produces the same exact outcome. It just is a cleaner way of doing that. And it's good to know. So try to learn how you can use the ternary operator, because a lot of times where that will come into play. Okay, so now what we're going to say, we want a condition for exiting out of the try switch, meaning we actually don't want to switch. And then we'll say if b is on equals b goal state, then return false. Then otherwise, we're going to say we're going to do different things based on whether the goal state is true or false. So if the goal state, then enter down, curly braces, enter, and then we'll do an else with curly braces, enter. And we're basically, this is going to be pretty straightforward, but we're just going to say switch on if it's that goal state. And then we're going to say if, let's say switch or on, what was the name of the variable we created? On button sound. If on button sound, so we actually have an assigned on button sound, then we're going to do play switch sound on button sound. And then semicolon at the end of that line. And then we're going to return true because we were successful. And then I'm just going to copy all of that in this if b goal state. Select it, Control C, under the else, Control V. And I'm going to do the switch off instead of switch on. And then if off button sound, play switch sound off button sound. And there we go. Then we have our get switch state, which is implementing the default, which will always return false. So now we want to do this return b is on. By the way, b at the beginning of this is just a naming convention that is typically used. It's not required, But this is often going to be like a good choice to just put B is on because it helps kind of follow a convention. This could have just been an is on variable. Okay, so now we're going to get into the slightly more interesting ones, which is under initialize component and uninitialized component. So first, if we go to, we're going to say we want to set this to generate overlap events, so that we know that that's that it will be able to do overlapping. So we're going to set generate overlap events true, then arrow right and semicolon. And then I'm going to say set collision profile name. And then we're going to make a text macro, parentheses, text, parentheses, quotations, overlap only pawn. And hopefully that's the correct spelling of that. But basically, this is going to make sure that we're filtering our collisions so that it's only going to be attempting to collide with the player or similar. Make a semicolon there. Close that line. And then what we need to do is we need to add a... we're going to use that on... We have it further down here, but the on overlap begin. We need to... add the binding for the on component begin overlap for this class, so that it will actually call the on overlap begin when we do this. And this is because of the way that the on component begin overlap is implemented, we need to use an add dynamic. So I'm going to type in this just so it's clear, and then the arrow on component begin overlap and dot add dynamic. And then I'm going to pass in this as the object. And then we're going to do the and symbol, u switch component on overlap begin, and then semicolon. And this will mean that our function that we just defined a little bit below, on overlap begin, is also going to fire when we when something overlaps this component. It's kind of a weird way of setting it up, but as far as I've found, there isn't another way for, even though this switch component inherits from a component that has on component begin overlap, they actually don't let you just override it directly. You actually have to call it and bind it to another function. So, and then the last thing we want to do here is if start with switch flipped, we want to switch on, and else we want to switch off. If B start with switch flipped, arrows, curly braces, enter, switch on, semicolon, arrow down, enter, else, enter, switch off, semicolon. And then now we need to go down to uninitialize component. And this is going to be very simple. We just want to make sure that we're removing this dynamic. And because there's an easy way to do this, we're just going to do this the easy way right now. I'm just going to put it before it does the super uninitialized component. That's not required, but sometimes it's a good idea when you're doing something that's initializing it, you want your code to run after the super already ran. And when you're uninitializing or destroying it, you usually want to put your code before the uninitialize or the destruction, because you don't know if the super uninitialized component might end up actually invalidating the work that you're trying to do. So you want to make sure that it actually gets called as opposed to like uninitializing the component, preventing that from happening. And now I don't know for sure that that's required with uninitialized component, but generally it's a good practice of like, if you're trying to reverse something, you just call the super after whatever your current instruction is. So then I'm going to do this arrow on component begin overlap dot remove all. And this, so we're going to pass in this object. And then arrow semicolon just to close out that line. And that's kind of it. That's all we need for uninitialized component. It's just a cleanup to make sure that we don't have any crashes or hanging references. So then now we want to go into our on begin overlap. We'll try to make this relatively simple. So the main thing we're worried about right here is the other actor. We don't really care about the other properties. We just want to make sure, because this is going to be colliding with the player, and we want to make sure that it only functions when it's colliding with the player correctly. So we're going to say, first of all, if not other actor, meaning there is no other actor, then we're just going to return. Then we're going to say we want to cast that other actor to our character, which is the power generator game character. So we're gonna, that we know that's an actor, so it's always going to start with an A, power generator game character, and it's an instance, so we want to do the asterisk, which by the way is Shift 8. And then we're going to say valid character is the name of this, and that's going to be equal to cast and less than a power generator game character, greater than, to close that off. So this is what it's going to be casting to, and then we need parentheses, and this we're going to plug in other actor as the variable. And then we can just put a semicolon at the end of that line. That means we're going to try to cast other actor as an A power generator game character. And then we'll say if parentheses valid character, we'll say if not valid character, return. So we're done because we don't have a valid character. Then what we're going to do is we're going to do one more check on the valid character, because if this did not return here, that means we do have a valid character. So then we can say if not, and then we'll say valid character arrow is locally controlled. And this just guarantees that it's checking that it actually is the playable local character, in case this character could in some places be used for a networked character or could be possessed by an AI or something like that. This is guaranteeing that it's actually controlled by a local player. So if not valid character is locally controlled, then that means if not is locally controlled, then we're going to return again. And then otherwise, then we do the try switch, and we pass in the valid character as the instigator. And so you'll notice in our try switch right now, we do have an instigator here, but we never use it for anything. That's something that we'll probably be able to do in the future, because we're when we have different ways of instituting the try switch, we can set different conditions about how it evaluates the instigator that you might use. And so in this case, we know that we only want to use the valid instigator in the from the on overlap begin, which is the other actor. So we're actually doing all of that ahead of time, and we're just passing that into the try switch. There might be other reasons that the try switch might have properties that would say, oh, it's player only, or that it's not, and we might change that in the future. But for right now, that's all we need to worry about. So we just have that try switch. And now we have just 3 more things we got to do here, and then we can jump onto the generator. So first, we have play switch sound. So if we were to jump into, say we don't know how we want to do this, and we have the blueprint, there's a fairly straightforward way to check. So I'm just going to show you that real quick by launching the... So if you don't know how to play a sound at location, which is what we use in the blueprint, you can always double click on a play sound at location node in a blueprint, and you can pull it up. But I'm not going to show you that here. I'm just going to show you what the code is that we're going to need for this. But remember, when you're trying to look at your blueprints and see what they did, you can always go through them and actually see what the code is calling to try to use the equivalent. So first I want to do if not sound to play, meaning we didn't actually pass in a value, we're going to just return, and that's just a safety check there. And then otherwise, what we're going to do is we're going to use a play sound at location that comes from a class called gameplay statics. So it's going to be gameplay statics, and this will be completed here. And then we do : so it's going to call a function that's in that class. And then we're going to do play sound at location. And I'm going to pass in 3 arguments. We only need 3 to get this to work, which is the world context, of which we can make this actor. So we just pass in this. Then the sound we want to play, and I'm just going to select sound to play, and then comma. And then I just want to use the location of the switch component. So I can just use get component location, which is going to retrieve the location of this component. And I'm going to hit a semicolon at the end of that line. Now, we actually didn't see this happen, but like just the act of selecting that we wanted to use this gameplay statics play sound at location actually automatically added the include for the gameplay statics, which is actually kismet/gameplaystatics.h. That's one of those other things that's super cool about how Rider works, is that Rider actually detects that gameplay statics exists before you set up the include, and it will automatically set up the include without interfering with your work. So if you didn't set it up that way, like say if you're working in Visual Studio will usually say it doesn't know what gameplay statics is, or it won't know what play sound at location is until you add the necessary include. So that's another reason that I suggest using Rider, because it's just way better. Okay, so we have this play switch sound, and now we just need to do the switch on and the switch off. And so if you remember from the blueprint version of this, we set the material on the switch to match the switch on and switch off materials. Then we set the value of the switch to is on true. And then we need to actually call the event, or we need to execute the event for our switch flipped delegate, so that the actor that owns the switch can know that the switch just changed. So first, I'm going to say if parentheses on button material, then make curly braces, and then we'll say this dot, or this arrow set material. And right now, all we care about is index 0, but if you have a more complicated mesh that has multiple material IDs, then this value might come into play because you might need to set a different material ID than the first one. But most objects, just by default, would just only have one material ID. So you only need this if you actually know that you have more than one material ID. So we're just going to set 0 for this. And then we're going to do on button material, semicolon. Then B is on equals true. And then we want to go to on switch flip delegate dot, and we could just execute this, but Unreal will actually likely crash if you try to execute a delegate that has no functions bound to it. So what we want to do is actually just execute if bound, which is the most straightforward way to make sure that this is going to work. And then we're going to pass in the value of true because the generator, when it receives this on switch flipped delegate, it also needs to receive the value true to know that the switch is on. And then we'll do a semicolon there. And then we're just going to copy all this from the switch on and go into the switch off, paste it. And then it's the off button material that we want here and here. So we're going to change that on to off in both of those. We know that B is on is actually now going to be false in the switch off. And then on switch flipped delegate execute if bound also needs to pass in that false. Now, I do want you to know that because there's so much overlap here, we could just make this a single function of like toggle switch. But just for now, I think it's a little bit cleaner to know that we know that we're going to be doing the switch on, and we know we're going to be doing the switch off. And if we end up finding that the behavior deviates significantly between switch on and switch off, sometimes it's actually better to have separate functions for it. That's really just kind of a preference thing, but that all should work. So now the only thing here is that this says the expression result is not used. This is actually, this is because this expression returns a bool, and Rider thinks that we want to utilize that bool, but in this case, we actually don't want to utilize the bool of determining whether or not it actually fired. So we don't need to do anything with that. Although it's showing the squiggly, we actually don't need to fix that. So I'm just going to hit Control-Shift-S to save all, and then I'm going to hit Control-B to build. And then assuming all goes well, we'll jump into the last part of this, which is just setting up the generator, and then setting up all of our actual blueprints to work how we need them to work. So, okay, that succeeded. So then next, let's do the generator.